hemostasis. Notice this is not homeostasis. And it revolves around your ability to stop loss of blood, which obviously is important. So hemostasis is the stoppage of bleeding. There are 3 phases to this. The first thing that happens if you cut yourself is the vessels that are exposed undergo spasm, which means they contract. They constrict the diameter of that vessel so that restricts blood loss. Platelets start to rupture, and when they do that, they release chemicals. And those chemicals are going to be very useful because later on they attract more platelets. You first of all have a spasm, and then platelets start to aggregate together and form a plug, and they stick to any exposed connective tissue. Then the third phase is something called coagulation, which is where the blood clots and it forms a solid mass. And this is quite a complicated process. It's not just drying out. Platelets release things called clotting factors, which help that clot form. So this is what happens if you have an injury. Blood now will start to leak out, but the exposed edges here will release chemicals, and those chemicals will cause smooth muscle spasm, causing the vessel diameter to reduce. Our next phase, we have what's called platelet plug formation. Because of these chemicals, plugs are now capable of sticking to this surface and blocking the vessel. And then what happens, the last part of this phase, is something called coagulation, where, if you remember back to the beginning of blood, we talked about a protein called fibrinogen. During this process, it's converted to fibrin, which form a solid plug. So now you've got a fibrous net, blood cells plugged to the hole, and now bleeding stops. It's very effective. Next time you poke your finger and you have a drop of blood and it stops, think about what actually had to happen to stop you bleeding. There are a lot of steps to this process, but notice you do not need to memorize them all. But understand a few things. If you're missing any one of the proteins that stops coagulation, then the process can't continue. It's a cascade. One thing happens, then the next, then the next. If you're missing one of the proteins in that chain of events, then coagulation doesn't occur, and that's the case in hemophiliacs. They lack one or more proteins. So that is a clotting disorder called hemophilia. Something else that's extremely important is calcium. For many of the steps towards clotting blood, calcium is required. Just a little look to see how complex this can get. There are 2 pathways. There's a pathway called an intrinsic pathway, where you have damage to a vessel wall, or extrinsic, where you have a trauma, which is where you cut yourself, poke yourself, something like that. They will eventually produce a clot, but there are many stages, as you can see. It's going from number 12 to 12A, 11 to 11A, and then it goes, if you notice, it goes straight to 9 without going to 10. These numbers don't represent a sequence, they represent how they were discovered. Both pathways end joining up together, a common set of proteins, eventually leading to something called prothrombin and thrombin, and then fibrinogen being converted to fibrin, and then you get your clot and your net of fibers. There are 2 chemicals it's important to know about. There's prothrombin and thrombin. These 2 you may often see if you ever see labs where people are concerned about how fast blood is clotting. There's something called the prothrombin time. So hemostasis is initiated 2 ways, by extrinsic. Extrinsic means damage to a tissue. This is where you cut yourself. Intrinsic, within the blood. Both of these pathways lead to the formation of prothrombinase. With the help of calcium, we end up with prothrombin. As we said, calcium is very important. So is vitamin K very important. So this is what you should know. You've got the 2 pathways, extrinsic and intrinsic, and they lead to this. And this is what I want you to know, that there's prothrombinase, calcium, prothrombin, thrombin, calcium, fibrinogen. Know that diagram and the components of it. A little bit of terminology. A thrombus is a clot within a vessel. So you may have a scab on your finger. You can get a similar kind of structure within a vessel, which is not a good thing. Considered intrinsic. You may have heard of coronary thrombosis. Coronary thrombosis means there's a clot in a vessel in your heart. Embolus is a thrombus that is moving. This can be very dangerous when a thrombus breaks free. It's going to travel somewhere, and eventually it will come across a vessel that's smaller than it is, and it will block it. Embolus or emboli are very dangerous. If it goes to your brain, that's a stroke. If it goes to the lungs, it's a pulmonary embolism. Or often, it's worth mentioning fibrin again. Fibrin, as we said, is the threads that form a net that trap cells and proteins to form a clot. When it forms, it sticks to either edge of the wound, and then it contracts. Effectively, it helps what's called approximate a wound. By, instead of leaving a wound this wide, the fibrin will pull the edges together when a clot forms. And the tighter the edges of a wound are together, the better they'll heal. So that ends our discussion on hemostasis. Our next one is about blood types. And we have 2 more presentations to go this week.